their notebooks open to the real number system page that we did yesterday. Better? Okay. Yesterday we went over the different types of real numbers. If I'm checking my squares, what types of real numbers do we have? What is our very basic number called? Natural numbers, and they include numbers like 1, 2, 3, 4. What about with our next one?
0.
0 gets added. What do we call those group of numbers?
Whole
numbers. Whole numbers are natural numbers plus 0, right? It's like every single little box includes the box within it. So natural numbers are their own thing. Whole numbers are whole numbers and natural numbers. Integers are whole numbers and natural numbers and integers. And rational numbers are integers, whole numbers, and natural numbers, right? They kind of just build up. Remember, you know what like a Venn diagram is where things overlap and you can tell which are kind of part of both? Same thing here. We could have done this with circles, but we did it with squares because the paper is square and it looks prettier. It's nice and organized, right? These are all real numbers. And then on this other side we have things like irrational numbers, which are kind of lonely. They're numbers that do what? They don't do what? They do something. How do we know something's an irrational number?
It's repeating.
If we have a non-repeating decimal, what's another way we know if it's going to be an irrational number?
When the numbers that cannot be expressed with fractions.
Right? We don't want, irrational ones are things that we cannot be expressed with fractions of integers. So if we have to do like decimals over decimals, not going to fly, right? And we know that integers are negative numbers and whole numbers. They don't include decimals until that point. Decimals are rational numbers. So if we have to include a decimal into a fraction, no go. Things like pi. Pi is your most popular irrational number. If you think of irrational numbers, you should be thinking of the symbol pi. We'll get used to pi. Pi Day comes in March 3.14. There are t-shirts and everything. You get to buy them with a party.
Oh, we have to buy it.
But you can also design them. There's like a competition. Yeah. Yes. People bring pie. We have a pie party. It's pretty awesome. It's one of my favorite days. Also happening this year, which I'm very, well not this year, but like next spring, and it has a lot to do with this. We have a square root day. We have a square root day. So by square root day is on April 4th, 2016. Okay? Or 4/4/16. Why would that be square root day?
4 times 4 is 16.
Square root of 16.
Because 4 is my square root of 16. Square root of 16 equals 4 because 4 times 4 equals 16. Right? There's another one in 2025 where it's 5/5/25. And then there'll be another one on June 6, 2036. But we're coming up on another one. And it's going to be during this. I think we should make a shirt for this.
Yeah. I have to.
Maybe you freshmen can do that as a class fundraiser. We can make square root day. That's just me. Alright, so yesterday we also started our next page of notes in our notebook. So make sure we're open to our September 3rd page. We wrote down in the top corner real numbers and the number line. I use my shorthand. And it's on page 16 of your book. And we started it yesterday on September 3rd. Yesterday we defined what this little symbol is right here. Right? What did we call this? It's a square root, but it has a special name. Guess what? It's a radical. And I'll zoom in for people in the back. We have a radical. What's the number inside called? A radicand. The square root undoes a square. Okay? Anytime we see an exponent up here that's a 2, that means it's a square. So if I were to say 3 squared, what would my answer be?
9.
9, right? Because that's 3 times 3. Anything it's going to be, it's equal to b times b. I can plug in any number I could possibly want. right? How do we know? Have we seen square roots before?
Yeah.
Yeah, so we know how we kind of are supposed to do that. So let's give an example. What's the square root of 81?
9.
Equals 9, right? Because underneath here, I want to put two different numbers that are the same, right? The radical of 81, I'll zoom in a little bit more for you. The square root of 81 is the same thing as square root of 9 times 9. And so I'm going to move that 9 to the outside. It's kind of like a little house. If there's two people in the house, they get to move outside the house. Two of the same people in the house. Right? So 9 and 9, they're partners, they're the same, they're going to move outside my house. If I wanted to simplify something that's not a perfect square, right? This is what we call a perfect square. Perfect square. We have nothing left over inside our little house and nothing inside our radical. If I wanted to simplify something that's not a perfect square, how can I break this down into multiples? What are my multiples of 8? So I've got 4 and 2. Can I break that down any further?
2.
Yeah.
I can go 2 and 2 and 2, right? So the same thing, I can split it into our little tree factors, right? Are we okay with finding factors of things? Multiples of things? Something we've seen before, maybe need a little bit of review. Since I know that 81 is a square root of 9 times 9, and I know that the factors of 8 are 2, 2, and 2, then that means I know that underneath my radical I've got 2 times 2 times 2. I can only move 2 things outside my house. There's an extra one. So if I move my 2 outside the house, they like group together and become one big thing. I still have one left over, and it's going to stay in the house until it finds a partner. Okay. So I'm going to move it to the outside, and it becomes its own person, and I have somebody left at the party by themselves. All right? So let's try another one. How about the square root of 12? What would I put as my factors of 12?
2 and 6, or yeah.
All right, so let's go with 2 and 6. Can I break that down further?
Yeah, 2, 3, 2.
2, 2, and 3, because I can break 6 down into here. All right, so I'm going to rewrite that with all my little numbers underneath my house. So I'm going to get 2 times 2 times 3. I need to move something to the outside. Which one do I have 2 of in my house? I have 2, right? So it means they group together. I like to think of it, if everybody plays Super Mario, they get like a little mushroom and he becomes bigger. That's too big for his house, and now they have to move outside. So my 2 gets to move outside the house, and I'm left over with what on the inside? 3. What about the square root of 18? Work on that one with your partner. Find my factors, and tell me what my radicals are going to end up being.
Square root
No, 3, 2, 3.
3 times 2, 6 times 3.
Yeah, so you can do 6.
3 square root 2.
So we're solving for the square root of 18. What are my factors of 18? All right, so let's write 9 times 2. Break the 9 down. Yep. All right, so now what's going to end up? So what moves to the outside of my house? 3. Can I have lunch with that? Perfect. All right, so let's see. Somebody tell me what my factors ended up being.
3, 2, 3, 2, 3, 2, 3.
2, 3, and 3. Right? Because I know it's 2 times 9. Move it so everybody can see it. So if I have in my house, I'm just going to rewrite it underneath my radical. 2, 3, and 3. What gets moved to the outside?
3.
My 3, because I've got 2 of them, right? I've got a pair in here, so they get to be their own separate party elsewhere. And I'm left with what? I'm left with a 2 in the house. So my square root of 18 is equal to 3 root 2. That's how we would say that. Say it with me. 3 root 2. This answer would be 2 root 3. Say it with me. 2 root 3. Right? That's proper mathematic terminology. 2 root 3, 2 root 2, 2 times the square root of 3. It's a big mouthful when you have to say square root of. Right? We want to put it down into one syllable. Root. And it makes a lot of sense for math. Are we okay with that? Are we okay with perfect squares? We talked about it a little bit yesterday, and I think a lot of people are pretty good with that, right? We know it undoes, or we know that a square root undoes a exponent of 2, and it just breaks it down into the individual part. I saw a drawing the other day, and if you want to write it down, it's cool. It's kind of the reason we call it a root. Well, you can think of it like this, right? If I had a 9, my 9 is in my tree. Oh, wait, sorry. I know that my roots are 3 and 3 because together they will build up into 9. It's kind of like they're the roots of a tree and 9 is my tree. If that helps anybody with pictures, that's cool. If not, if you just want to know, we can move on that way too. So we're talking about simplifying. Are we okay simplifying this way with even numbers?
Yeah.
Let's say I give you one, however, that looks like square root of 15.
Be 3 and 5, and then it will be 3 root 5.
But I only have one of each number, right? I can't move anything outside. So I've got 3 times 5. Do I have does anybody in my little house party here have a partner?
No.
No. So can I move anything to the outside? No. So what we're going to do is we're going to estimate. We're going to estimate my root by making a guess. All right? Your first step to estimating is finding the 2 closest perfect squares. Right? Find the 2 closest perfect squares.
Love it.
Perfect. There's a Q, U, A, R. Squares. Find the 2 closest perfect squares. So if I have the square root of 15, put it up here. What are the 2 closest perfect squares of 15? 15 is not a perfect square is, what is that one? 16 is a perfect square. So there's the closest one that's greater than. What's the closest one less than?
14.
So 14 would be an even number, but is it a perfect square? Can I divide it to get one whole number?
12.
What's the square root of 12?
Oh.
There's none.
There is none. So what's the square root? Here's another idea of how we can think about it. What's the square root of 16?
4.
What's 1 less than 4? So what's my perfect?
Wait, wouldn't 2?
Oh, okay.
Or 9?
2 would work, but there's a 9 is the closest one, right? Because between 9 and 16.
Not 2, I meant 4. 4 would be
Yep, and that's where we get the 16 from, right? So my perfect squares that I'm trying to find are going to be between square root of 9 and square root of 16, which means my answer is going to be somewhere between 3 and 4. Is it going to be closer to 3 or is it going to be closer to 4? 4. How do I know that? What tells me that it's going to be closer to 4? Because 16 and 15 are pretty darn close together. It's going to be close to 4. Right? So I can say that my square root of 15 is going to be approximately 4. This little squiggly line means approximate, or almost, or about. Approximate. What's the other way we could find the square root of 15 without estimating? It's cool, you just type in buttons somewhere.
Calculator?
Go with calculator, right? What we're going to do in our assignment today is going to be more like this. Okay? So let's do another example problem. I'm going to move, my paper's falling off. I'm going to flip my page over just so you can see it. Let's do the square root of 20. 29. Move it down where there's less dots. So if I know that I've got the square root of 29, I'm going to find my two closest squares. I know one of them is going to be square root of 25, because that's going to be a perfect square, and my other one's going to be the square root of 36. 5 and 6, right? 5 squared is 25, 6 squared is 36. I'm thinking about it, 29 is only 4 away from 25, so it's a difference of 4. And it's about 7 away from 36, which tells me that my answer is going to be closer to my 5. So I can assume that my answer is going to be approximate. Make it sure it's squiggly so I can tell the difference. 5. What about the square root of 45? What are my perfect squares? Closest perfect squares. Somebody give me one of them. 49? So 40, I got 49. Square root of 49 is one close. What's my answer to square root of 49?
7.
7, right? That's going to be my perfect square. What's on the other side? If I've got 7, I have one more less than that, which is going to be my 6. So it's my perfect square I'm looking for. Right? It's going to be 36. I heard it in the back. When you're looking for the ones that are between my two endpoints, we'll call these the end radicals. If I can identify one, so I'm looking 45, hey, that's pretty close to 49, and I know that that's a square root, that's a perfect square, right? That's going to be, the answer is going to be 7. I just have to move one more back to 6. Okay? There's only going to be a difference of 1 between these two numbers. Okay? Does that make sense? So if I know this is 1 and 7, my other square root is going to be square root of 36 of 6 squared. Yeah? No? Kind of? I'm figuring out how we go from here. So which number am I closer to? I'm closer to 7, which means my answer is going to be what? Approximately 7. How do I make my approximate? Squiggly equal sign. My squiggly equal sign. So it would be approximately 7. Good? Good, okay? Are we okay with this estimating? You'll have to estimate a little bit on your homework tonight. Okay? How comfortable are we with square roots?
Oh, that's great.
Yeah? Good. Then I'm going to give you one to work on with your partner for a second. Yeah. You ready for this? I want you to estimate the square root of 386. We'll have to think about this one. Estimate your square root of 386.
What is the number?
386.
I see the tape.
I know I made it hard. Right?
No, I said,
What's our first way we're going to try and find out if it's how do we find out if that's a perfect square? What's our first step in finding out if that's going to be a perfect square? Does anybody know if it's a perfect square?
no, it's not.
No. So how do we decide if it's a perfect square? What do we need to do to find out?
Divide by 2.
We need to break it into our factors, so divide by 2. So I've got 2. What's 386 divided by 2?
193.
And 193. Can I break 193 up into anything?
No,
Nope. Okay, so is it a perfect square?
no.
No. Uh-oh. So now we have to find our two closest. Our two closest roots. Okay. When we're doing big numbers, here's a hint for you. Try and go to the next, 100. We want even numbers and we want them to be big. So let's 100?
400.
400, is that a perfect square?
Yes.
What is it, what's its square root of 400?
20. How do you
So my close, that's not, just kidding, 400. So I'm going to go up to my closest 100. That's going to be the best way to do this. This will be the hardest problem you have to do today, I promise. Go up to you go up to your closest 100. And Michael has told me that the square root of 400 is 20. Which means my other root is going to be the square root of what? What's going to be my... 19, right? So what's 19 squared?
361?
361?
Yeah.
361. All right. So I've got 386. Am I closer to 400 or am I closer to 361?
400.
I'm going to be closer to 400. So my answer is going to be approximately what? 20, right? I need to put the answer is going to be the perfect square number. Making sense so far? So far we've gone over the types of numbers. And square roots like these fall into places like these, right? Perfect squares fall into our rational number section in the real numbers, right? Non-perfect squares will fall into our irrational, right? Perfect squares, imperfect squares. Perfect squares, imperfect squares. What is this? Perfect squares. What's a perfect square? How do I know it's going to be a perfect square? If I can take the square root and what do I get as an answer? A whole number. When am I going to get an irrational number? When it's not a perfect square, right? Because we're going to get decimals that go all sorts of which ways. Good? How many know what this sign means?
Greater than.
What about this sign?
Less than.
What about this sign?
Equal than.
Less than or equal to.
Less than.
Right.
So I've got,
Greater, that's greater than.
Greater.
Or equal to.
Less than or equal to.
so I've got greater than, less than, right? This is because it opens wide to the big one, small to the small one. Less than, greater than, or equal to, and less than or equal to. What's this sign? Good guess.
Equal than.
Good guess. Have we seen these symbols before?
Yes.
Yeah, I think so.